All right, close them up for a second. Let's have a little look. So, click them all the way closed when everybody's catching up here. So let's have a look at an example like the one you were just doing, right? So, if we look at an example like this where they're giving us a 0 of f of x, and they want us to find all of the real zeros. That one and the other ones included. Okay, so everybody, Sean, close that up. Everybody should be closed up. Riley, close it up, please. Okay, so now what? All right, so what does this mean, first of all? If I've got something like f of 3 equals 0, what's the number that's a 0 of the function? 3, because when I plug 3 in, I get back 0 for the function, right? Okay, so what's another way of saying that then? Fill in the blanks for me. Another way of saying that is blank is a factor of f of x.
And the function is 0.
Well, so, but I mean, what's a factor of f of x? So what's a polynomial that's going to divide evenly into f of x? If f of 3 is 0, then what's something I could divide x cubed plus 7x squared minus 14x minus 48 by? And let's just do that. We'll color code this. So let's make this yellow. So if I divide x cubed plus 7x squared minus 14x minus 48 by something, I should get back some answer plus 0 remainder on the top. What? What was it? X minus 3. Exactly, right? So x minus 3 is a factor of that then. If I divide that in there, I'm going to get something back with no remainder. And I know I'm getting no remainder because the remainder is equal to the value of the function when I plug that 0 in, right? That's the, what did we call that yesterday? That's the remainder theorem, right? So we know that this is a factor. So all I've got to do is divide this out, right? We'll just divide it out synthetically. So what's that going to look like then? If I do my synthetic division process, what number goes out front? Negative 3. That should have been a plus, shouldn't it, actually? Because I'm doing x, oh, no, actually, hang on. It was right. I messed that up. What number goes out front? 3. Okay, because that's the 0. That's what goes out front. What are the coefficients going to be that go across the top? 1. There's my 1. 7. And negative 48, right? And what's going to be in the remainder box? 0. Right? They tell us it's a 0. Okay? And so if we do the synthetic division here, so we're getting hopefully pretty good at that. What do I do to do the synthetic division? Drop the 1 down. Good. Now what? Times 3 is 3. So if I add those, I get 10. Times 3. Add those and I get 16. Good. And then times 3. And sure enough, they add to 0, right? So what's that telling me then? It's telling me that if I divide the yellow polynomial by the orange factor, I get the result 1x squared plus 10x plus 16, right? That's what those numbers at the bottom mean. They're the coefficients. So then I'm getting back x squared plus 10x plus 16 plus, I didn't need to write this, but I know I've got 0 remainder over x minus 3. I don't even need that though, do I? That just all goes away. right? So then what's that tell me? If I want to write this as a product, what times what equals the yellow polynomial? X minus 3 times that thing, right? Right? Isn't that what that means? We looked at an example yesterday where we did something like that, where we said 54 divided by 6 equals what? 9, right? And so if we write that as a product, what do we say? What times what equals what? Yeah, good. 6 times 9 equals 54, right? So there's an example. I mean, that's how it works with numbers, same way with polynomials. That times that must equal that because that divided in evenly, right? Okay, and so then what are we doing with all this stuff? Well, all we're going to say is if we're trying to find all of the zeros of this function, we're just starting off with the original polynomial equaling 0, but we're going to break that up into factors. That's what this whole thing was, right? The factors, it's going to break up into x minus 3 times x squared plus 10x plus 16, and that product has to equal 0, right? Well, we already have 1. We know that 1, 0 is 3. That was given to us. All we got to do is take the other polynomial and find its zeros, right? How are we going to do that? I mean, we're just going to set the quadratic equation, or set the quadratic expression equal to 0, right? So if we set the factor equal to 0, how are we going to solve that one? We could use quadratic formula, but is there a shortcut? Is there an easier way? Can we find magic numbers, in other words? What are they, Leon? What are numbers that multiply to 16 and add to 10? 8 and 2. Good. So this one breaks up into x plus 8 and x plus 2. So what are my other zeros? Negative. Good. Negative 8. There's 1. And negative 2, right? So that seems like a lot of stuff, doesn't it? But did we really have to do all that? No. What's the part that we really needed to do? We could have just done this part right here, really, right? Because we know we're going to plug, this is my 0, so it's what goes out front. We know that that has to divide evenly into this, so I'm going to get a 0 back. Here are the coefficients, and really all we needed to do was just take this simple little quadratic polynomial and set it equal to 0 and solve. We could have jumped right to the other answers, couldn't we? Right? If we look at this, like let's just verify if I show a graph of this thing. So there's the function, right? There it is. Right, there's the function. Everybody agree? If we find the zeros of that function, what are they? Well, one of them's at negative 8, one of them's at negative 2, and one of them's at 3. Right, so we just found them. Okay? All right, let's try one more. So what about something like this guy? What am I going to do this time? This time let's just jump right to the answer. I want to find all the zeros. What's one of them? Negative 10. Okay, so we'll make a list up here, right? We've got x equals negative 10 is 1. How am I going to find the others? What goes out front? Negative 10. Good, so negative 10's out there. What are the coefficients going to be? And what has to go in there? 0. So we know it has to. If it doesn't, we made a mistake. All right, so then if we bring the 3 down, 3 times negative 10? Negative 10. So that gives us what, 10? What goes here?
Negative 100.
Plus 102 is 2.
Negative 1.
So it works, doesn't it? Right? So then all we got to do to find the other zeros is solve that quadratic equation. Well, think about this one now. This is going to be 3x squared plus 10x plus 2 equals 0, right? Are we going to be able to find magic numbers on that? No. I mean, maybe we could, but we don't even want to bother because a is not equal to 1. A is not equal to 1. What are we going to do? Quadratic formula. And so really, do we even need to write anything down? I mean, we know what A is. That's B. And that's C. Just plug that stuff into the quadratic formula, right? So we get x equals what then?
Negative 10.
Negative b, which is 10. Good. Plus or minus the square root of b squared. What's that?
100.
Minus 4 times 3 times 2, right? All divided by what?
2 times
2 times 3, which is 6. Okay. So we get negative 10 plus or minus the square root of 100 minus 24. So 76. All divided by 6. I know that those two things are not going to combine, right? So I can just split that up and do negative 10 over 6 plus or minus. Now, what's the square root of 76 going to be? If I do a factor tree for 76, what are the factors of 76? It's even, right? So I know 2 works. 2 times, what, 38? What's 38 break up into? 2 and 19. Okay, so look, there's a couple, there's a single. So what do we get? Square root of 76 becomes
2 out of 19.
right? All divided by 6. And so I could simplify this a little bit. Negative 10 over 6 reduces to what?
Negative 5 over 3.
Okay, plus or minus. What about this one here? Can I reduce that?
Yes.
What could I do to reduce it?
1.
Okay, good. I can't, the 19 is inside the radical, so it's off limits. But the 2 out front and the 6 would reduce to 1 and 3. So how would I write 1 times the square root of 19?
Square root of
Square root of 19. So there are my other 2 answers, right? I'm going to get negative 5/3 plus radical 19 over 3, negative 5/3 minus radical 19 over 3. Okay? What about something like this guy? Okay, what about something like this? This time they're asking us to find intersections of curves, right? Points of intersection. So I've got this f of x is this curve and g of x is this other curve, and I want to know where they intersect. Okay, now let's think about this in terms of what we do when we're trying to find intersections. What's going to be true here? The points of intersection are going to be the places where the same x and y values work for both equations, right? If I look at a graph of this, here's what it looks like. So the red function is the first one, that's f of x, and the blue one is g of x. Here's just a picture of those graphs. Well, notice that there's 3 places where they intersect, at 5, negative 5, negative 5, negative 5, 3, negative 29, and 4, negative 41. So if I were to plug in negative 5 in for x in the red equation, what am I going to get back?
Negative 5.
Negative 5. If I plug negative 5 into the blue equation, what am I going to get back?
Negative 5.
Negative 5, right? If you think about, now think about this graph for a second. If I look, for example, at the blue graph, you guys know you've done t-tables many times. If I were to just make a t-table and put in an infinite number of x values, if I plotted all those infinite ordered pairs and put them together, they would just create that smooth graph, right? For example, when I plugged in negative 5, I would get negative 5 on the, negative 5 in for x on the t-table, I'd get negative 5 for y on the t-table, right? These happen to be the 3 places where those 2 t-tables would have the same ordered pairs, but those are the only 3 places, right? So when we ask the math gods, where the functions intersect, really what are we doing? We're just asking the question, when does this equation equal that equation, right? Really all we're saying is, when does the red equation, x cubed minus 3x squared minus 28x plus 55 equal the blue equation, negative x squared minus 5x minus 5. So that's how we ask the math gods where these things intersect. They're going to tell us with algebra, if I solve this thing, there's only x's in this equation, so they're going to give me back the x values where they intersect. And then to find the y values, what could I do? Like for example, if I know that negative 5 is an x value that works, how could I find the y value? I could plug it into which one? Either one, it shouldn't matter, right? Because by definition, this is the point of intersection is where they both have the same y value, right? So then all we've got to do is take this equation and solve it, right? Okay, so there it is. We're just going to solve that equation. How would I go about solving that equation? What do I always do to solve a polynomial equation? Okay, move everything over to which side this time? Left side, because I want a positive number for my leading coefficient, right? So we end up with the equation x cubed. If I'm going to add x squared to negative 3x squared, I'd get negative 2x squared, right? Add 5x to negative 28x, and I get negative 23x. And if I add 5 to 55, I get 60. Well, look, they tell us, right from the beginning, they tell us that this is the x value for one of the places where they intersect, one of the points of intersection. So if that's a place where they intersect, then that must be a solution to this equation. It must be a 0. Agreed? If I plug that in, I would have to get 0, and I would. So this is just like the last thing we did, isn't it? Right? The only difference is we had to come up with the original equation that we get that we need to solve, right? So if I make my, we won't even do the whole thing, but if I were to, I guess we could, it'd be pretty quick. If I were to make my synthetic bracket, what number goes out here? Negative 5, right? That's a solution, okay? What are the coefficients that go here? 1, negative 2, okay? And what has to go in there? 0. 0 has to go in there because it's equal to 0, right? We're finding the zeros of this expression. So now if I just do the math, this part's easy. Bring the 1 down. What's 1 times negative 5? Plus negative 2 times negative 5 plus negative 23, 12 times negative 5. So it works. Okay, well, if those are my values of A, B, and C, there are magic numbers this time, aren't there? Right? What would they have to multiply to? 12 and add to negative 7, right? So what are those numbers? Almost. You have to multiply to a positive and add to a negative.
Negative 3 and 4.
Negative 3 and negative 4, right? So we know that this factors into, right? So what are the solutions? X equals, or x equals 3, or we already had x equals negative 5, right? So all I would have to do is just plug each of those, into one of those functions to find the y values, then we got the ordered pairs, right? Okay? All right, last thing. So that's a small step forward, right? That's no big deal. The thing you just did, that's just an application of it. Yep. That's all we have to do, just an application. Okay, so the very last thing, and this is it, very last thing would be to do a problem like this one, okay? where this time the difference is they're not helping us at all. They're not giving us any of the x values that are zeros. Okay, so there's a trick though. There's a trick that we could generate a list of values to try and see which one gives us a 0 in the remainder box, and then that's going to be the value we'd start with. For example, in this problem back here, they told us that -10 was a 0, right? This time they're not telling us that. We got to find one on our own. But here's the trick. It's called the rational root theorem, and it's really simple. All it says is that all of the rational zeros, rational just means fractional, right? All the zeros that could be written as fractions must be included in the list that we build when we create fractions where the numerator is going to be a factor of the constant and the denominator is going to be a factor of the leading coefficient. Okay? So all we got to do is make a list of the factors of the constant. So what are the factors of 10, of -10? Start with the smallest.
2 and negative.
Well, but something even smaller than 2 divides into 10. 1 does, right? So 1, and I really could include both plus or minus 1, right? What's next? Plus or minus 2. Okay, good. Now, while we're at it, let's do factors of the leading coefficient, which is 2. Plus or minus 1, right? But being as we're going to make fractions out of these things, and the top is already plus or minus, we don't even have to put the plus or minus on the bottom part, right? So just 1 or 2, okay? And so what are all the fractions we could build with yellow denominators, or yellow numerators and green denominators? Starting with the simplest. So our list would look like, let's first of all divide by 1, because dividing by 1 is easy, right? It means I just get all these numbers in the yellow list divided by 1 doesn't change them. So I get plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Now what if this time I divide by 2? Some of them don't even change. 2 divided by 2 is what?
1.
So that one's already on the list, right? Don't even need it. 10 divided by 2 is 5, so those are already on the list. 1 divided by 2, that's a new one. So I've got 1/2, and then 5 divided by 2 would be 5/2. It's much harder to deal with the fractions, so we'll do those last. And I already told you guys, this year I'm not going to make you do synthetic division with fractions. So I will never give you a problem where at least one of these integers doesn't work, right? So we'll just start with the easiest one and work our way down the list. Now, what are the odds? I just happen to have a bracket built for that. That's cool. That's great. Total accident. So what number, where do those numbers come from? Just the coefficients, right? So there's the coefficients, and I'm just going to keep trying numbers from this list until I get what?
0.
Till I get a 0 in the remainder box, right? So I need to get a 0 there. So let's start with the easiest one. Let's start with 1. If I put a 1 out front, we can just zip through this. What am I going to get? 2 times 1 is 2 plus 3. 5 times 1 is 5. That's not going to work, is it? I can already see I'm not going to get 0 there. So that one's done. We can cross positive 1 off the list. Let's try negative 1. Okay, so negative 1. Bring down the 2. Negative 1 times 2. Add them up. 1. Negative 1 times 1. That's going to work. If I add those, I get negative 10, and negative 1 times negative 10. And so they do add to 0. So negative 1's a winner, right? So there's 1 0. Now the rest is easy. I've already got the coefficients there, right? Negative 1 is a 0, so now I just have to find the zeros of this polynomial, right? Well, that's just 2x squared plus x minus 10. Do I want to look for magic numbers?
No.
No, I've got a 2 there instead of a 1. So that's just A, B, and C. What do?
Quadratic.
Quadratic formulas. So x is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, right? So that's just going to give me, okay, what am I going to get if I multiply negative 4 times 2 times negative 10? 80. Negative times negative is positive, right? So I'm going to get the square root of 81 all over 4. Well, what's the square root of 81? 9. So if I take the plus, negative 1 plus 9 is 8 over 4. Robert, what's 8 over 4?
8 over 4?
Mm-hmm.
2.
2. Okay, so there's 1. Let's take the minus. Robert, if I take the minus, what's negative 1 minus 9? Almost. Negative 1 minus 9?
Negative 10.
Negative 10 over 4. What's that reduced to?
Negative 5 over 2.
So what are my 3 solutions?
Negative 1, 2, and negative 5.
Yeah, negative 1, 2, and negative 5 halves. I got it. What's the only difference? I had to figure out what one of the zeros was on my own. And the way I did that was I just made a list, right? Factors of negative 10 on the top, factors of 2 on the bottom, and just work my way through the list. There is kind of a shortcut way to do this list, right? So we could, and you might like this. This actually saves a lot of time and space. I'll just show it to you real quick. It's not essential, but it's pretty helpful. So, oops, that's not working. So here's kind of a shortcut way to do that, right? You could do nested synthetic division. So all you do here is we're just going to write down the coefficients, which are, and we'll make a line, vertical line. Coefficients are 2, 3, negative 9, negative 10. And then we'll just put the zeros that we're trying out front, right? So if we try, for example, positive 1, what do we get? Well, we're going to do all the stuff in our head this time. So we're going to do, bring down the 2 times 1 is 2, right? Or bring down the 2, sorry. 2 times 1 is what? Plus 3. See, I just put the stuff below, I do the stuff in my head, and the stuff below the bar is what I write here. 5 times 1 is 5, good. Plus negative 9. Negative 1 times negative 4 plus negative 10. So it didn't work, did it? Now, really what I'm trying to do is get zeros in the last spot. So that one we can cross off. Let's try negative 1. I got the right coefficients, didn't I? 2, 3, negative, yeah. Okay, show that negative 1 does work. I bring down the 2. 2 times negative 1 is negative 2 plus 3, 1. Negative 1 times 1 is plus 9. Negative 1 times negative 10 is plus negative 10, 0. So that one worked, right? And if it didn't, we would cross it off and go to the next one. That way you can try a whole bunch of them really quickly if you use that technique. You don't have to. You can draw a bracket out each time if you want to. But that's the way I would do it. It's a little quicker. Okay? Make sense? It's a lot, but that's it. That's it for about 2 weeks. There's nothing new coming up. It's just we'll review next week, but that's it. Okay? All right, how much time we got? Go for 4 minutes.